Hello pre-calculus students, and welcome to video part 2 of an introduction to the conic sections. And so we're looking at the 4 different conic sections: parabolas, circles, ellipses, and hyperbolas. We've talked a little bit about the general form of a conic section, how to tell which conic section you're looking at, and then we delved into 2 kind of challenging problems with conic sections. One of them was a parabola, which is just challenging because the way that it's on the same side of the equal sign, it just makes a little bit more of a challenge. And then the next example was challenging because we had fraction here. We had an odd number for our b, and so when we have to cut that in half, we have to end up with a fraction. Okay, but now we're going to look at a couple of slightly more straightforward problems. Okay, so let's look at the same idea here. This time we have a negative. And when we have a negative, when either a or c is negative, I'm talking about the square terms now, always the square terms. When either one of them is negative, we're looking at a hyperbola. So this is a hyperbola, okay? And the directions for completing the square in a hyperbola is basically the same as a circle and ellipse. The only thing is that we want to put the positive term first. That's all that this is saying, is just if c is the negative term, you're going to put that one second. That means a is the positive term. So we're just going to look at this one and focus on that aspect of the square terms. And we can see that the y squared term is the positive, the x squared term is the negative. And so we're going to put these in order with the y squared term first. So we have 16y squared, and we're going to group it with the minus 224y. And then the x term, so minus, actually I'm going to put, I like to put plus and minus here, so plus a negative x squared plus 4x, and then put that 716 on the other side, so subtract that from both sides. Okay, so this is what we're going to start with. Now we still have to factor out the 16 here, so when we factor out the 16, what do we get? We get 16 times y squared minus, and 16 goes evenly into 224. Just get your calculator, and 224 divided by 16 is 14. So this is minus 14y. And then we're going to leave room to add something to complete the square. Okay, whatever we add, we're really adding 16 times more, but the beauty of this problem is that this is even, while the thing that made the last problem harder was that this was odd. This one here was an odd number, and we're left with an even. We call this the linear term, is an even coefficient. Okay, let's do the same thing with the x. Now what I like to do here is I put a plus or minus, but I still like to factor out the negative 1. Okay, and then we have, we don't have to take anything else out. We just have x squared. Now just be careful, because if I take out a negative 1 here, this is going to be minus 4x. Let's leave some room to complete the square, and then let's finish this off. Okay, so this equals negative 716. But don't forget, it doesn't just equal negative 716. We're going to add whatever we put here times 16 and whatever we put here times negative 1. So we're going to be adding a couple things here as we complete the square. Okay, so what do? Half of this is negative 7. Negative 7 squared is 49. And then we have to get our calculator and multiply 49 times 16 to see what goes here. And 49 times 16 is 1649. 1649. All right, here, this is going to be negative 2 squared, which is plus 4. So when we add 4, we're really subtracting 4 from this side. So if we're subtracting 4 from this side, we should probably subtract 4 from this side. Okay? And there we go. So now we're ready to write this as graphing form. So let's just write this as 16 times, and this is a perfect square of y minus half of that, y minus 7. This is minus 1 times, and this is a perfect square of x minus 2, so x minus 2 squared. And that equals, and when we add all of these together on the right side, we are going to get 64. me just check that. Okay, we will get 64, but this is a mistake. This is just, I just wrote these together, 1649. So the product of 16 times 49 is not 1649. It's actually 784. So this is 784. Now it makes more sense when we add these together. The numbers are a bit smaller, and when we add these all together, we do get 64. And that is the square form of the hyperbola. We just have one more step to put it into parabola form. I mean, not parabola, but graphing form. So let's just write our completed the square forms. We have 16 times y minus 7 squared minus 1 times, we just say minus x minus 2 squared equals 64. And the last step to get this ready to graph is to just divide everything by 64 so that this is a 1. Same way that we did that. We did the same thing. Well, we haven't done it yet. We haven't had an ellipse yet. So we divide both sides by 64 and we get y minus 7 squared over 16 over 64 is 1/4 minus x minus 2 squared over, and then this over 64 is just 64, and that equals 1. Now that's graph ready. That's our graph ready form of a hyperbola. Okay, next example is going to be an ellipse. So let's look at our ellipse. We've already determined that it's an ellipse because both the x squared and the y squared term are positive, but they're not the same. If they were the same, it would be a circle. Being different, it's an ellipse. When it's an ellipse, we just put these in order with the x squareds first. So I'm just going to rewrite this as 4x squared plus 40x, and then plus 9y squared minus 162y. And then I'm going to subtract this from both sides, so minus 793. Okay, and now I'm going to factor out the 4 and set it up to complete the square. So I'm going to factor out a 4, and I get x squared plus 10x plus a space to complete the square. I'm going to factor out a 9, so plus 9 times y squared. 9 goes evenly into this 20 times, so minus 20y. And we'll leave room to complete the square. So we'll leave a space there to complete the square. And then that equals negative 793, and then we have to add the two things that we're going to add here, so I'm just going to put the spaces to add them. So again, I'm just setting it up to complete the square at the moment. So plus the two things, whatever we find there. So we're going to find them now. Okay, so for the first one, it's going to be half of 10 squared, which is 25. So I added 25 in here, which means that what I really added to the left side is 4 25s, or 100. So that's what's going to come over in this first space here is 100. And now let's complete the square on the y's. So we're going to take negative 10 squared, which is 100. So we're going to put 100 in here, which means we're really adding 9 times 100, or 900. So this is 900. Okay, a little correction here is that I factored out wrong. So when I took out the 9 here, 9 times 20 doesn't equal 162. 9 times 18 equals 162. So this should have been an 18. So let's just fix that, make that an 18. And that means when I multiply here, I'm supposed to take 9, half of that, which is 9. 9 squared is not 100. 9 squared is 81. All right, and then the last correction is that when I take 9 times 81, instead of getting 900, I get 729. Okay, so there it is, completed this. Well, we still have to write it as perfect squares now, so I'm just going to write this as 4 times half of that, so it's x plus 5 squared. And then 9 times y minus half of that, which is 9, so that's going to be y minus 9 quantity squared. And then when I add up all these numbers to the right, I add them all up and they come out to 36. So this is 36. And that's completed the square for this, this ellipse. So we can write that in the complete the square spot. So right here is going to be 4 times x plus 5 squared plus 9 times y minus 9 squared equals 36. And just one more simple step to get this graph ready is to set it equal to 1, so divide everything by 36. So 4 over 36 gives us a 12, so this is going to be, I'll just write it like this, x plus 5 squared over 12, that's 4 over 36. 9 over 36 is 4, so this is y minus 9 squared over 4. And of course, the reason we divided by 36 is because 36 over 36 is 1. Okay, now we have our ellipse all ready to graph, which will be in the next class. Okay, let's do the last one. Actually, I'm going to pause it and give you guys a chance to try this simpler circle. So let's make sure we can all complete the square in the circle. A little bit simpler because you don't have to factor anything out because there's no leading coefficient here. So let's give it a try. Let's rearrange, complete the square. You should get something that's a perfect square on the right side when you're all done. All right, so sometimes there's fewer steps and it can be confusing because like, what do I do when there's only just an x squared there? Well, you've already got that perfect square. This is kind of like x minus 0 squared. In other words, the x-coordinate of the center of the circle is just 0. The y-coordinate is at 4. Okay, so here's the completing the square. When we add the 16 to both sides, we get a perfect square of 49. That is completing the square version for a circle. And with circles, we don't have to do anything to write it in graph-ready form. We will have to think of this as something squared. You might remember that the radius would be 7 in this case. The center would be at 0, 4. And that's all we need to graph a circle. That's going to be part of the next lesson. Okay, I hope you found this video helpful.